Assalamu alaikum. Welcome to my channel Jahangir'S Science School. Today I am going to discuss about very fundamental thing. What is electric current? Electric current. Electric current. We know electric current equal to rate of flow of charge. So normally electric current is the rate of flow of charge. That means the amount of charge flowing through a conductor perpendicularly within 1 second is called electric current. So electric current, mathematically we can write electric current equal to charge divided by time. So electric current symbol is I equal to Q divided by T. Electric current I equal to Q divided by T. So unit of electric current is ampere short from A, and unit of charge is coulomb, and unit of time is second. Coulomb per second is known as ampere. Electric current is a scalar quantity because it is the rate of flow of charge. Charge is scalar, time is scalar, so ratio of two scalar must be a scalar. So electric current, say this one is a conducting wire, and there is a cross-sectional area. If there are Q amount charge here, and after T time, this Q amount charge crosses the cross-sectional area say A. After T time, this Q amount charge crosses the cross-sectional area perpendicularly. So electric current is the amount of electric charge flowing through a cross-sectional area of a conductor perpendicularly within 1 second is called electric current. So the amount of electric charge flowing through a conductor flowing through a cross-sectional area of a conductor perpendicularly within 1 second is called electric current. Is called electric current. Say within T second, the amount of charge flowing through the cross-sectional area of a conductor is Q. So within T second, the amount of charge flowing through the cross-sectional area is say within T second, the amount of charge flowing through the conductor is Q coulomb. So within 1 second, the amount of charge flowing Q by T. So we know within 1 second the amount of charge flowing through a conductor cross-sectional area of a conductor perpendicularly is called electric current. That's why electric current I equals to Q by T. There is a formula triangle. So I equal to Q divided by T. So if we want to find out charge equal to current into time. So charge equal to current into time. So Electric current is the rate of flow of charge. So electric current equal to charge divided by time. Electric current is denoted by I equals to Q divided by T. Unit of current is ampere. So remember, 1 ampere means if 1 coulomb charge flowing through a conductor within 1 second is called 1 ampere current. So 1 ampere current means 1 ampere equals to 1 coulomb per second. 1 coulomb per second. Now we have to learn about voltage or electric potential. Electric potential or voltage. Electric potential or voltage. Voltage equal to energy transfer per unit charge. Energy transfer per unit charge. So voltage is denoted by V. So energy per unit charge. Unit of voltage is volt. Short form is V. And unit of energy is joule. Unit of charge is coulomb. Joule per coulomb. So 1 volt equal to 1 joule per coulomb. If amount of energy is 1 joule carrying by 1 coulomb charge, then that amount voltage is called 1 volt. 1 volt. So now electrical resistance. What is electrical resistance? Electrical resistance, the property of the material which opposes the flow of current flowing through a material is called electrical resistance. Say when electric current flowing through a material or conductor, then a lot of collision occurs between the vibrating molecules or ions present in the material and moving electron. Say electron, this one is the electron flowing through the conductor, and inside a material lot of ions or molecules present and they are vibrating. When electron flows through the material, then lot of collision occurs between moving electron and vibrating ions. So the property of the material, which opposes the flow of current, through the material is called electrical resistance. So resistance is the property of the material which opposes the flow of current through the material is called electrical resistance. We can calculate resistance by using the formula resistance equal to voltage divided by current. We can calculate resistance by using this formula voltage divided by current. If we want to measure the resistance of this resistor, then we need an ammeter ammeter to measure the current flowing through it, and we need a power supply, DC power supply, and a switch, and we need a voltmeter to measure the voltage or potential difference across the resistor. This one is the fixed resistor. We want to measure the resistance of the resistor. Then we need a ammeter measure the current flowing through the resistor, and we need a voltmeter must be connected in parallel across the resistor. There is a battery and there is a switch. So by using this formula, resistance equal to voltage divided by current, we easily calculate the resistance. Remember, unit of resistance is ohm. So unit of resistance is ohm. We write the symbol of ohm like this, ohm symbol, and so volt, V, and ampere. So ohm, 1 ohm equal to 1 volt per ampere. Volt per ampere is known as ohm. Now electric circuit. First we have to learn about what is circuit or electric circuit. Electric circuit is a complete closed path through which electric current can flow. So a complete closed path through which electric current can flow is called electric circuit. So a complete closed path through which electric current can flow is called electric circuit. Say there is a battery or cell. Say this one is a cell. Larger one is positive terminal and it is a negative terminal. Positive terminal known as higher potential and negative terminal is lower potential. If there is a bulb and there is a switch, say switch, K switch, and this one is the battery. This one is a simple circuit. It is bulb or lamp. This one is a simple circuit. So simple circuit. In switch there is a language switch. When switch is closed, then it is on. When a switch is open, remember open means off. Switch is off. There are two types of electrical circuit. One is series circuit, another is parallel circuit. What is series circuit? If circuit's components are connected in such a way that same current, series circuit. Say if the circuit's components are connected in such a way that same current flowing through all the components, then it is called series circuit. There is no alternating path. That means there is no alternating path. If circuit's components are connected, say this one is a bulb 1, here it is bulb 2, and here it is bulb 3. These three bulbs are connected in such a way that same current will flow through all the components. Then it is called series circuit. Remember, in series circuit, current remains same. So current in the series circuit is same because there is no alternating path. There is only a single path. But voltage divided. That means in series circuit, if the total voltage or EMF of the battery is V, then this voltage divided among the components. So V1 plus V2 plus V3. But remember, current remains same. So in series circuit, current remains same. Current remains same. In series circuit, if resistors are connected in this way, say this one the resistance R1 and another is resistance R2, they are connected in series because there is no alternating path of current flow. Then total equivalent series resistance, then total equivalent series resistance will be, say, series resistance, that's why RS, so R1 plus R2. So total series resistance will be R1 plus R2. If more resistor, then we add same way. Then if the voltage is V, then total current will be total current in the circuit I equal to total voltage in the battery divided by total resistance in the series circuit. But remember, in series circuit, voltage across each resistor, individual resistor will be different. So if we want to calculate the voltage across the each resistor separately in series circuit, then so voltage, the potential difference or voltage across the resistor R1 will be V1 equal to I into R1, because in series circuit current is same, so that's why I into R1. The potential difference or voltage across the resistor R2 will be V2 equal to I into R2, because in series circuit same current flowing through all the components, so same amount current flowing through R1 and R2. That's why if we want to calculate the voltage across R1, then formula will be V1 equal to I into R1. I is the total current in the series circuit, and R1 is the resistance of the resistor R1, first one, and V2 equal to I into R2. Now we want to solve parallel circuit. What is parallel circuit? Parallel circuit. In parallel circuit, circuit's components are connected in such a way that there is a lot of alternating path. So here R1 and R2 are connected in such a way that there is a lot of alternating path of current flow. So this one is the parallel circuit. So here it is positive terminal, negative terminal, current flowing through this, then divided among R1 and R2. I1 current flowing through R1 and I2 current flowing through R2. So R2, and total current again becomes I. So total current is I. So series circuit, if circuit's components are connected in such a way that different current flowing through the components individually divided among the components, but the voltage across each component remains same. then it is called parallel circuit. So in parallel circuit, current divided but voltage across each component remains same. So here remember one interesting thing, if we want to calculate the total resistance, total equivalent resistance, equivalent parallel resistance, RP. Remember here 1 by RP equal to 1 divided by R1 plus 1 divided by R2. This is the formula for calculating total equivalent resistance, parallel resistance. So RP equal to 1 divided by R1 plus 1 divided by R2, then reciprocal it. So this is the total formula for total equivalent parallel resistance. This is the formula for total equivalent parallel resistance. And total current in the circuit is I equal to V divided by RP. P is the total equivalent parallel resistance. Remember, to calculate the individual current flowing through individual resistor or component, we have to first calculate the parallel voltage here. So parallel voltage, remember parallel voltage Vp equal to I into Rp. So in parallel circuit, voltage remains same. So parallel voltage, this one same voltage as battery. So same voltage. That's why current flowing through R1 flowing through R1 resistor is I1 equal to Vp divided by R1. So current flowing through R1 resistor is I1. So I1 equals to Vp parallel voltage divided by resistance R1, and current flowing through R2 resistor will be I2 equal to Vp divided by R2. So in parallel circuit, remember current divided. So total current divided among the branch. So total current divided among the branch. So I1 current flowing through R1 resistor and I2 current flowing through R2 resistor. But voltage across each component remains same. So this is the formula for total equivalent parallel resistance. We know I divided by Rp. Rp is the total resistance equivalent parallel resistance. So 1 divided by R1 plus 1 divided by R2. So Rp equals to 1 divided by R1 plus 1 divided by R2 and inverse. So total current I equal to V divided by Rp. So parallel voltage Vp equal to I into Rp, and current flowing through R1 resistor I1 equal to Vp by R1, current flowing through R2 resistor I2 equal to Vp by R2.